Good morning, students. Hope all of you are fine. So this is for standard 9th, the third lesson that I will be delivering. So I, Jivan Kumar Pandey, first welcome you all to this third lesson. Till now we have already discussed, as you can see on the board, path length, displacement, average speed and average velocity. But we have discussed them in context of one-dimensional motion or straight line motion. Today we will discuss few problems pertaining to the same things but in two dimensions. So let's see. As you can see on the board, there is a semicircular track starting from A. The question is like this. So this is first question in two dimensions. Now the path is no longer straight, it is in two dimensions, it is in a plane. A body starts from point A, moves in a semicircular track and reaches to point B and stops there. This circle has a radius of 14 meters and the time that the body takes to move from A to B, this time is given as 2 minutes. You have to find all the four parameters, that is path length, then displacement, then average speed and average velocity. We have to find these four things, so one by one we shall discuss them all. First of all, we will start with path length. Path length we already know, it's nothing but the distance traveled. So path length will be, here this is the path. I am putting the arrow mark, starts from A and moves to B. Now if it were a full circle, then that path would be equal to circumference. Here it's half circle, so it's half the circumference of full circle. Circumference or perimeter of a circle, students, you know it is 2 pi r. But since it's half circle, it will be only half into 2 pi r, that is pi r. So we can calculate it, pi is 22 by 7. Radius of this path is given 14 meters, so this becomes how much? 44 meters. Once we have got the path length, then we can find the displacement. Can you guess, students, what should be displacement? Displacement, if you remember, while discussing that I have told you that you should remove the path, forget about the path, forget about this path. Just see where are the initial and final positions. So the initial and final positions are at A and B respectively. Then join the initial and final positions by a straight line, like so. Then that length gives the value of displacement. Can you guess what will be that length? Is it not the diameter of this circle? Whatever circle the particle has moved, this displacement, that is the length from A to B, is nothing but diameter of that circle. So displacement is equal to diameter of that circle, and that will be just twice of a radius, and therefore this becomes 14 meter. Is this statement complete? No. Whenever you write displacement, have the habit of indicating the direction. So displacement is 14 meters, its direction is from initial position A to final position B, and that's why I have put an arrow over there. Once you have found path length and displacement, the other things can easily be calculated. Third one is average speed. Tell me, students, what should be the formula for average speed? It's very simple. It's path length divided by time. What is our path length? Our path length is 44 meters. And what is the time? It's given in the question that the time taken to move from A to B is nothing but 2 minutes. So 2 minutes I can convert in seconds using this. This can be calculated, you will get the answer in meters per second. And the last part, that is the average velocity, can also be likewise found. Average velocity magnitude will be displacement upon time. Now what is the displacement value? Displacement value is 14 meters and time is again 2 into 60 seconds. So you will get some meters per second as your answer. Here you find that the value of average speed and average velocity will be different because the values of path length and displacement are also different. Do you think average velocity also we should indicate the direction? Of course yes. Why yes? Because it is dependent upon displacement. I have told in the last class, displacement is a vector, that's why average velocity is also a vector quantity. So after writing the answer, you should write the direction. Its direction is also from where to where? A to B. This is the direction of average velocity. So distance, that is path length, and average speed have only values, they are scalars, but displacement and average velocities, they have some magnitude as well as some direction. I hope it is clear. Here we have next question. This is question number 2. Here the path is square. A particle starts from A. This is initial point, which I have indicated by red dot. It then moves to B, then to C, then to D and back to A along the square path. And it is given that each side of this square is 2 meters and the time taken to move from A to B, B to C, C to D, D to A, all the times, 4 times are same and each is equal to 1 minute. So you have to find the path length, displacement, average speed and average velocity. First one, path length. Path length is nothing but the distance traveled. It is very simple. It is the path from starting point A to final point, that is also A. The particle comes back to the point A. So path length is AB plus BC plus CD plus DA. This on calculation how much will you get? 2 plus 2 plus 2 plus 2, that is total of 8 meters. Okay. Now tell me, how will you find displacement? Displacement I have told it is the straight line. Magnitude of displacement is the length of the straight line joining the initial to the final position. But in this case students, the initial and final points are the same. That's why the particle, since it comes back to its original configuration, original position, that's why it has zero displacement. And therefore we will not associate any direction. It is a zero vector, we say. Next we have to find average speed. So average speed will be path length divided by time. Path length is 8 meters and time is the total time. Now for each of the side it takes a time of 1 minute. So the total time will be 1 plus 1 plus 1 plus 1, that is 4 minutes. 4 minutes you will convert in seconds by multiplying by 60. This can be calculated, you will get some answer in meters per second. And at last we have average velocity. The average velocity is nothing but displacement by time. Displacement, how do we calculate? Final position minus initial position by time in one dimension. But here we are talking in 2 dimensions, so we will not use the symbol x. Anyway, displacement we have calculated 0. So 0 upon any finite number is also 0. So the average velocity will be 0 meters per second. See students, while the average speed is finite, it has some value, but the average velocity might be 0. In any question, if the particle comes back to its initial position, then its displacement as well as average velocity will be 0. Okay, the next topic that I would like to discuss is acceleration. The term acceleration is defined as rate of change of velocity. This is the definition for acceleration. Velocity we already know, it is the rate of change of displacement or position. So mathematically we can write acceleration will denote by symbol A. So acceleration A is equal to rate of change of velocity, means change in velocity divided by time. So this is the mathematical formulation for acceleration. It is defined as change in velocity. In fact, this is the formula for average acceleration. So far whatever we are discussing is speed, velocity, and now acceleration, we are discussing the average values. So it will be better if you write A average. Later on we will discuss about instantaneous values also, but for the time being I am writing it simply as A. So if we denote by U the initial velocity and we use V to denote final velocity, then the average velocity, average acceleration. Now when I write initial and final velocities, that means the velocity has changed from value U to value V, and we are discussing now one dimensional motion. In fact, in this chapter we have to discuss only about straight line motion. So in a straight line there is a body which is moving, it is having some velocity U, and after some time its velocity becomes V. This velocity changes in time t. So t is the time during which velocity changes from U to V. Then the average acceleration is defined as change in velocity, that is final velocity minus initial velocity, by t. Average acceleration, if you denote as A, then we will write as V minus U by t. So what should be the SI unit for acceleration? You can see, students, this is change in velocity. Velocity unit is meter per second, and this is time. Time SI unit is second. So its SI unit should be meter per second and by second, or this can be written as meters per second square. It can also be written as meter by second square. Likewise, the CGS unit you can guess yourself. The CGS unit will be, for acceleration, it will be centimeters per second square, which can also be written like so. Let's try to understand this with the help of one example. You can see the question on the board. It reads, a train starting from rest moves with uniform acceleration. Uniform acceleration means the acceleration which we have defined as rate of change of velocity is uniform. What does that mean? That means simply that the velocity is changing by equal amounts in equal intervals of time. That means velocity is changing at a uniform rate. Starting from rest, that means its initial velocity. The initial velocity, what symbol we have used, students? U. The initial velocity of the train is how much? 0. That is the meaning of rest. It was not moving. Now it moves with constant acceleration. Acceleration is constant, but we have to find the value of acceleration, find its acceleration. So acceleration is question mark. And it is given in the question, the train attains a speed of 40 kilometers per hour in 10 minutes. So time is given 10 minutes. Minutes will convert in SI system, that is seconds, by multiplying by 60. So this becomes 600 seconds. The final speed, which will denote by V, final velocity, is 40 again. The unit is not in SI system. It is 40 kilometers per hour. No problem. We can easily convert in meters per second. So this we can write as 40. Now kilometer, how do we convert in meters? By multiplying by 1000. And hour, how do we convert in seconds? By multiply. 1 hour is 60 minutes and 1 minute is 60 seconds. So this way. Often people remember this value also. You can see these two zeros will cancel. It will become 5 by 18. So this becomes 40 into 5 upon 18 meters per second. See, kilometer I have converted into 1000 meters and 1 hour I have written as 60 into 60 seconds. So we have got some value, this much meter per second is the assignment for this. I think I should suggest you, of course this is the proper way, but you can remember also, instead of writing this you can write directly 40 kilometers per hour is 40 into 5 by 18 meter per second. How that 5 by 18 comes is clear from here. So u is known, initial velocity, final velocity v is known, time is known, and we have to find acceleration. When acceleration is constant, we can write the average acceleration is same as instantaneous acceleration, and therefore it is given as the rate of change of velocity, which we can write as v minus u upon t. Instead of v we'll put this value, instead of u we'll put 0, and in place of t we'll put 600. So this becomes 40 into 5 by 18 minus 0 and divided by t. T is 600. What should be the unit, students? Can you guess? Acceleration SI unit is meters per second square. Rest is calculation. You can easily calculate that value. You will get some meters per second square. Okay. Now let us briefly discuss what are the meanings for uniform acceleration and non-uniform acceleration. As the name suggests, uniform acceleration means acceleration is constant. Acceleration is constant means the definition for acceleration says it is nothing but rate of change of velocity. So that must be a constant. What does this mean? This means that velocity should change at constant rate. If this condition is satisfied, we will say that acceleration is uniform. For example, at t is equal to 1 second, suppose the velocity is, I am writing here time and I am writing here velocity. So t, we start from t is equal to 0, then 1 second, 2 second, 3 second, time is in seconds and velocity is in meters per second, 4, 5 and so on. When t was 0, suppose the speed was also 0. At t is equal to 1, suppose the speed has increased to 3 meters per second. At t is equal to 2, it becomes 6 meters per second. At 3, time 3 seconds, it becomes 9. Then 4, it becomes 12 and so on. This is an example for uniform acceleration. You see, in the first 1 second, the velocity has increased from 0 to 3, that is by 3 units. So the change in velocity is 3 meters per second in 1 second. So the acceleration comes out to be how much? V minus u upon t. 3 minus 0 upon 1, that is 3 meters per second square. I will choose this interval. In this time interval, that is 3 to 4, again the time interval is of 1 second and the velocity changes from 9 to 12. So what is the change in velocity? Change in velocity is from 9 to 12, that is 12 minus 9, that is 3 meters per second. If this is the change in velocity, how much will be acceleration? Acceleration will be change in velocity by time, that is 3 meters per second square, which is same as this value. In fact, for any interval, if you choose for this interval, that is from 2 seconds to 4 seconds, what is the time taken? 2 to 4, time taken is 2 seconds. Here velocity was 6, here velocity is 12. So what is the change in velocity? From 6 to 12, that is how much? 12 minus 6, that is 6 meters per second. So in 2 seconds, the change in velocity is 6 meters per second. Therefore, what will be the acceleration, students? Acceleration will be change in velocity, that is 6, by time, that is 2, that is how much? 3 meters per second square. You choose whichsoever interval you want. in any interval you will always find, whether the interval is big or the interval is small, in any interval you will find the value of acceleration in this particular example to be 3 meters per second square. So this is an example for uniform acceleration. And if this condition is not satisfied, that means velocity does not change at constant rate. Here instead of 6 if I make it 5, instead of 9 if I make it 11, instead of 3 I make it something else, then the velocity will change in unequal amounts, in equal intervals. Then the acceleration is said to be non-uniform. So this is the difference between uniform and non-uniform acceleration. Having discussed today average speed and average velocity in 2 dimensions, and also the definition for acceleration and uniform and non-uniform acceleration, I would like you to do these 2 questions. First one, there is a circular track. A particle starts from A and completes one round in some given time as given in the question. You have to find all the 4 parameters. And second question is that a stone is thrown vertically upward. It goes to a height of 20 meters from the ground and then falls back to the initial position. Again, you have to find all those parameters. What I want you to think in this particular question is that whether this motion of the stone, up and down motion, is it accelerated motion? If it is accelerated motion, what is its direction? Well, I have not told you yet that acceleration is also a vector quantity like displacement and velocity. So in our list of vector quantities, we have got so far 3 quantities. First one is displacement. Rate of change of displacement we write as velocity, and rate of change of velocity we write as acceleration. So remember students, all these 3 and some more which we will discuss in this course of standard 9th, all these 3 are, so far we have come to know about these 3 vector quantities. That means all of them have magnitude and direction. If so, then you should think that what should be the direction of acceleration when a stone is thrown vertically upward. I'll stop here students. So come prepared in the next class. Next class we'll switch over to some graphical aspects of motion. For that I'll be discussing slope and area under curve. So waiting for you. See you in the next class. Thank you.